This video is an extension to the series of the ds-incubator about Docker. And here I'm going to be talking about named volumes. The star of the show is going to be this entity called volumes. So we can do a Docker volume ls to show you here some volumes that I have in my system. How do you create them? You create them with docker create, volume, docker volume create, and you give them a name. So that's why they are called named volumes. Let's call this one test. So why are they useful? Well, they're useful because they create think of it as a folder in your system, but in a part that is managed by Docker, that allows you to mount that folder in any container that you create. Either if it's just ephemeral or persistent, those containers can have access to a persistent data. So that allows you to display a polymorphic behavior in the containers that you run. Even if you run the same container multiple times, so if you but if you do it with different data, then you can display different behavior with that container. So that is a very powerful idea that container that Docker enables through the use of these volumes that are going to persist in your system. So let's explore this idea a little bit. So we now do a Docker volume ls, and we should see our test volume there. It's empty so far, and we can start adding some data to it. How do you populate volumes in Docker? You do it with containers. So you can do, let's do a Docker run. Let's run an ephemeral container that's going to be interactive of the, and let's use an image that is easy to work with, small, and allows me to just have a shell there. Let's do Ubuntu. So that would run an Ubuntu, would give me a shell that I can start working with. And to populate that container, I'm going to be using the -v flag for volume. And as usual, you now map in this case, something on the host side of the system and something on the container, right? But what we're going to be doing is we're going to just pass the name of the volume that we want to use, and we're going to map it to a particular location in the system. Let's pass it to TMP, for example. So now if I run this container, I can change directory to TMP. And if I do an ls, I will see that this directory is empty. Let's create some files. Let's touch A and let's touch B. So if I do an ls, those files are there. And the beauty of this is that if I exit this container, I can show you that I have no container now running. The beauty of that is that the volume actually now has been populated with that. How do we know that? We can do a Docker volume inspect test. Here we see a directory that is where the Docker volume is storing the data. So I could do this is a privileged action, so I need to do a sudo ls for that specific directory. I need to enter my password here. Let's see, Docker volume ls. I'm making some mistake there. Let's do a Docker volume inspect test again. Let's see, once again, copying this file. I know what I did wrong there. Let's do a sudo ls for, I think I did not paste the leading, the first slash. Okay, so here you see that a volume is aware of these two data sets that I created, two files that I created, A and B. So now I can access those files from a new container. I have no container running, but I can create a new one. Let's do something just like we did before, and another container of Ubuntu mapped in the same location than the one before. And it's going to be using the name volume test. So if I run that container, even when this is a fresh container that has no data, if I do a cd to TMP and show you the contents, we will see that it's now populated with A and B. So that is a way then that you can use to, for example, store R packages that you install in one image you can store them so that you can reuse them with different images or different containers, more properly speaking. So let's exit this and show you what I mean. So for that, we are going to be running an image of, let's call this our libs. So first, let's create that volume called our lib. So docker volume create our lib, libs, our lib is enough. Docker volume ls will show me that that exists there, and that volume is now empty, right? It has nothing in it. There's no content. I can actually do a docker volume inspect to see our lib, to see the directory where it stores data, and if I did an ls on this, I should see that this is empty, right? Just to confirm, we can do a sudo ls on that, and you can see that there's no output, right? It's empty. Let's repeat that just to confirm. So what I could do now is docker run. I could run an R-based container mapping that rlib. Rlib, was that the name of it? Docker volume ls rlib. Yeah, that was the name I gave it to it. So let's map the volume rlib to a location where the image needs packages to be installed. So let's pretend that we still don't know that. So let's explore where that location could be. Let's run for that an image from the Rockerverse project. So let's say that I'm going to be using a lot of images that use R3.6, and then, well, it would be useful for me to have a persistent record of those packages that I install, so I don't need to reinstall them every time that I need to use a container that is using R3.6. So let's start with bash here, just to explore where I would be mapping the rlib volume. So if I run R, I can explore where the R libraries are installed with dot lib paths. So that function will give you the addresses where R will store the packages that it installs. So if any package is installed in that place, it's gonna be available in your computer, and so we call it is. So we say it is installed, right? So what I notice here is that both of these directories start with /user/local/lib/r, and then they differ just in the last bit here. One is site library and that one is library. So we could map both of them to our new volume, or what I could do is also map them both to just the let's do rlib. So what I'm gonna do is just map only the first part. So use R local lib and R. So if I make that directory available, if I share that directory between containers and the volume, both of these paths are going to know where to look for things, right? So let's run that. Blah blah blah. So now what I can do is spin R and try to install a package that doesn't exist here. Let's see. One thing I need to check first is what is the repos option, because Rverse 3.6 was locked with in this date. So let's run that. So you can see that, well, not in this date, but close to that date. So that this version was released on April, but was valid all the way until July 2019. And then it was all the the packages that are going to be installed will be looking for this specific snapshot or CRAN. So instead, what I want to do is I may want to set the option repos to something more general, like https CRAN rstudio.com. And now if I install packages, they will be pulled from the most recent version of cron. So what we want to freeze here is the version of R, but we want to be using updated versions of the packages. So to demonstrate the use of volumes, let's say that we want to use the package R2DAI data. Let's see if that is available in this system. It says that it's not. Then we're gonna be installing it. Let's install that package. R2DAI data. Let's clear this up to show things a little clearer. So now I'm going to install this package, and the usefulness of volumes then is that as I install this package, it is being stored in the volume that I created. So I can now exit this container. So let's prove that it worked. R2DAI data. We proved that it works because we didn't get an error when we call library this time. Let's exit this container. And now let's inspect the volume that we have, docker volume inspect rlib. Again, this is the path where all the data is being stored. So let's copy this path here and do a sudo ls on that. Here you can see there is a couple of directories. Remember library and site library. So if we do site library, we can see there is a bunch of packages here installed, and it should include the R2AI data package that we just installed. Is it there? I don't see it there. How about in, here it is, R2AI data. So there is the package installed. So that means that the volume now, the package that we installed persists in the volume, although the container that we created with is dead. So let's confirm that, docker ps -a, there is no container running. If I do another container, docker run, I could now again reuse. So I'm going to be running a new container, fresh container of this image Rockerverse, again with 3.6, because the versions of R, if I'm going to reuse the library, it has to belong to the same version of R. But notice that now reusing the volume, right, mapping it again to use R local lib /R. So with that, that means that if I run R and if I do a library R2AI data, this should work because the package is installed. Even when this container is fresh, it is looking at installed packages that I stored in the named volume. Okay, and with that, we can finish this extension of the ds-incubator series about Docker, having now learned a little bit more about volumes. In particular, this was the use of named volumes. Thank you, and see you next time.